To start off, today we're going to cover a few topics, but the main topic is called the unit circle, how to construct it. Okay. These are the main topics for this week. Construct the unit circle, explain the three main components of the unit circle, convert radians to degrees, convert degrees to radians. There's two special triangles to find points. Find the 6 trigonometric functions, applications with trigonometric functions. And let me go back real quick, you go more. And trig functions with any angle. Okay, now, this is a unit circle that students need to know, okay? Now, if an instructor will tell you, construct the circle, what will be your reaction? Well, right, it's overwhelming because it's too much material to try to memorize or to understand. So I have like a unique way to help you construct your unit circle and actually know it, not just memorize it, but know it by heart. Okay? And let me tell you what the unit circle is. The unit circle is on the coordinate plane, right? You see, if you notice, it's 1 unit. Okay? So now let's enlarge it. So this point here, guys, what wasn't it? 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So these are the three components that you need to know: radians, degrees, and the points. Okay, now the unit circle goes counterclockwise. Okay, we start with 0, and then if we do a complete turn, right, and radians is going to be 2 pi. So if this is 0 and go in a complete turn around the circle, or a complete turn around the circle, then over here where the negative 1, 0 is, it's going to be pi, right? Because if this is 0 and the whole circle is 2 pi, so half will be pi. And what's half a pi? Half a pi will just be half a pi. And what's half between pi and 2 pi will be 3 pi over 2. So these are the radians. Now in degrees, right? So again, degrees, right? For degrees, this is 0 degrees, and a complete circle is 360 degrees. And half of 360 will give you 180. And half of 80 will give you 90. And what's between 180, what's half of 180 and 360 will be 270. So these are my degrees. Okay, now, if you notice, every denominator with a 6 in the bottom, this is your point. If you notice, we have pi over 6, right? We have the square root of 3 over 2 and 1/2. Over here in quadrant 2, we have pi over 6, but we have negative square root of 3 over 2, 1/2. You see, it's the same point on every quadrant, but the thing is, you have to follow the signs of each quadrant. And the pi over 4, everything with a 4 on the bottom as a denominator, this is your point. You see, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And the same thing with a pi over 3, with anything in the denominator with the 3 in the bottom, this is my point. 1/2 the square root of 3 over 2. You see, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. You see, they all have the same point, but the quadrant is what tells us if it's positive or negative. You see, quadrant 1, everything's positive. Quadrant 2, the x is negative and the y is positive. Quadrant 3, they're both negative. And quadrant 4 is going to be positive, negative. Okay, now we're going to focus on these 3 points, on these 3 radians here. Anything with a 6 in the bottom as a denominator, anything with a 4 in the bottom as a denominator, and everything with a 3 in the bottom on the denominator. That makes the whole unit circle. Okay? Okay, now I'm going to do it in 2 parts. Okay? And this is how I tell my students, the first day of class, when I teach 2412, even though the inner circle is explained in 4.2 kind of briefly, but I like to start out with the inner circle because it's the most important and the most impactful topic on this course on 2412, and also on the calculus and more advanced math classes to come. Okay, so first we're going to start with radians. Okay, we're going to cut the circle in 8 equal parts. You see, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we start with 0. Okay, we're going to start counting by pi over 4. And every time I'm going to add pi over 4 and pi over 4. Okay, I'm going to keep adding pi over 4. Here we go. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Now these that are going to highlight can be reduced. You see, 2 pi over 4 will be pi over 2. 4 pi over 4 will give us pi. 6 pi over 4 will give us 3 pi over 2. And 8 pi over 4 will give us 2 pi. Okay? That's the radians. Now comes the degrees. Okay? Degrees, right? We're going to start with 0. And if you notice, we're gonna add 45 degrees, because if we divide 360 by 45, because we know the whole circle is 360 degrees, a complete circle. If we cut it in, if we divide it in 8 equal parts, it's going to be 45 degrees. Anyway, we should know that this is a right triangle here, right? And we know a right triangle, or the right angle, has 90 degrees. So we're going to count by 45 degrees, and we're going to keep adding 45 degrees. So we start with 0, 45 degrees, 90 degrees. 90 plus 45 was 135. 135 plus 45 will give us 180. 180 plus 45 will give us 225. 225 plus 45 will give us 270. And 270 plus 45 will give us 315. And finally, 315 plus 45 will give us a 360. Okay. Okay, now comes the points. Okay, the points, guys, there's only 3 points that you gotta know. Remember the 3 points? That was pi over 6, pi over 3, and pi over 4. There's only 3 points that you need to know. And those come from 2 special triangles, okay, which I'm going to explain later on in this PowerPoint. Now, if we notice, right, these are always the same points, right? The 1, 0, 0, 1, negative 1, 0, and 0, 1, because this is 1 unit, right, on the coordinate plane. Now, if you know the distance, right, this is the distance for the x. This is the distance for the y, right? If you notice, they're equal to each other. That means the points must be the same. So everything with the 4 in the bottom as a denominator, this is your point. But depending on the quadrant, right, it determines if it's positive or negative. So the 3 pi over 4 is in quadrant 2. So it's going to be negative and a positive. Quadrant 3, which is a 5 pi over 4, will be, both are going to be negative. So it'll be negative square root of 2 over 2 and negative square root of 2 over 2. And here, the 7 pi over 4 is in quadrant 4. That's going to be positive and a negative. The square root of 2 over 2 and negative square root of 2 over 2. You see, guys, we're done with the first part. And I tell my students for them to construct it, right, in 2 parts. So this is the first part. We're done with part 1. Okay, now, if you notice, now we're going to cut it. This is part 2. We're going to cut it into 12 equal parts. There's right. So each quadrant gets cut into 3 parts, 3 equal parts. Okay. Now we're going to get the radians. So here, okay, we're going to start with 0, and remember, we're going to go counterclockwise. Now here, we're going to count by pi over 6. Okay. So we'll start with pi over 6, and then 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 7 pi over 6, 6 pi over 6, I'm sorry, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. Now these can be reduced. That can be reduced. The 3 pi over 6 can be reduced. The 4 pi over 6 can be reduced. The 6 pi over 6 can be reduced. The 8 pi over 6 also can be reduced. The 9 pi over 6, the 10 pi over 6, and the 12 pi over 6. Okay, now 2 pi over 6 will give us pi over 3. 3 pi over 6 will give us pi over 2. 4 pi over 6 will give us 2 pi over 3. And 6 pi over 6 will give us pi. 8 pi over 6 will give us 4 pi over 3. 9 pi over 6 simplifies to 3 pi over 2. And 10 pi over 6 reduces to 5 pi over 3. And finally, 12 pi over 6 simplifies to 2 pi. We're done with the radians. Now comes the degrees. For the degrees, right, if it's cut into 12 equal parts, if we divide 360 by 12, it's going to give us 30. So we're going to count by 30 degrees. Okay, we're going to keep adding 30 degrees. We start with 0. 30 degrees, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. Okay, we're done with radians, we're done with degrees. Now finally comes the points. Okay. Now, if we can recall, guys, everything with a 6 in the bottom, the point is going to be the square root of 3 over 2, 1/2. Okay, oh yeah, I forgot these right here. Those will always be the same, right? And 0, -1. Now comes everything with a 6 in the bottom. It would be square root of 3 over 2, 1/2. And now we have another 6 in the bottom of the denominator of 5 pi over 6. So that's going to be negative square root of 3 over 2, 1/2. We have 7 pi over 6. That both are going to be negative. So it's going to be negative square root of 3 over 2 and negative 1/2. And on quadrant 4, we have 11 pi over 6, which is going to be positive and a negative square root of 3 over 2 and negative 1/2. Because if you notice the pattern, there's only one, for example, with a denominator of 6 in the bottom, there's only one in each quadrant. And same thing with everything with the 3 in the bottom as a denominator, there's only one in each quadrant. And same thing with the pi over 4, right, which was the previous, which was part 1, there's only one in each quadrant. Okay, now comes the 60 degrees or the pi over 3. The point is the same same one for pi over 6, but the only difference is that you switch them. With 1/2 goes first and the square root of 3 over 2 goes second. And we just know the quadrant. This is quadrant 1, so everything is positive. Quadrant 2, here the 2 pi over 3 will be negative 1/2 and square root of 3 over 2. In quadrant 3, at 240 degrees, right, or 4 pi over 3 is going to give us, both are going to be negative. Negative square root of 3 over 2, negative 1/2 and negative square root of 3 over 2. And in quadrant 4, we have 5 pi over 3 is going to give us a positive 1/2 and negative square root of 3 over 2. You see, guys, we're done with part 2. And now, what we do, now we put them together, both parts. Remember from the first part, the pi over 4, right, was here in the middle. Right? So the one in pink is a pi over 4. So this is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now with the degrees, this was 45 degrees. I believe this will give us, well, I believe 135. This will give us 135, will give us 180. This will give us 225. And I believe this will give us 315. Well, anyway, guys, you can get them right because if 5 pi over 3 is 300 and 11 pi over 6 is 330, half of that will be 315. That's another way to get the answer, guys, right? So it's always in between. So between 120 and 150, right, is 135. That's where the 3 pi over 4 goes. Same thing between 210 and 240 is 225, right? You can do it that way. And then comes my points, right? Everything with a 4 in the bottom as the denominator, the points are the same, the x and the y value. So I'll be square root of 2 over 2, square root of 2 over 2. But in quadrant 2, it's going to be negative and a positive. In quadrant 3, it's going to be both negative. In quadrant 4, at 315 or 7 pi over 4, is going to give us a positive and a negative. Square root of 2 over 2 and negative square root of 2 over 2. You see, guys, we're done with a circle. Okay? And then I tell my students to put it to practice because I quiz them on every exam. I mean, I gave them a quiz first, and then on exam 1, the circle is going to be there. They got another circle. On the final exam, they have to know the circle. Why is the circle important? Again, I mean, the unit circle, because it's used in every math class after 2412. It's always used, I think, even in engineering courses. So it's very crucial for students to understand the importance of the unit circle. Now, let's summary on constructing the unit circle. Remember, guys, part 1, we divide the circle in 8 equal parts. This is like, like the summary, right? And then we're going to go counterclockwise. We start with 0, and we keep adding pi over 4, 2 pi over 4, 3 pi over 4, until we get to 8 pi over 4. 8 pi over 4 should be here where the 2 pi is, right? And then we simplify. The second part, again, now comes the degrees. We start with 0, and we keep adding 45 degrees until we come to 360. And then finally, every radian with a 4 in the denominator has a point of square root of 2 over 2, square root of 2 over 2. But you have to make sure that the signs match the quadrants. Okay. Now, let's summarize part 2. Right? We divide the circle into 12 equal parts. And then here, guys, right, we start with 0. And then we keep adding pi over 6. Pi over 0, and then pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, all the way to 12, and then we simplify. That's for the radian. For the degrees, we start with 0, and we go away. We keep adding 30 until we get to 360. Okay, so you add 30, and then 60, 90, and so forth, all the way around, and then where the 0 is, it's supposed to be the same thing as 360. And every radian with a 6 in the denominator has a point of square root of 3 over 2, 1/2. And every radian with a 3 in the denominator has a point of 1/2 square root of 3 over 2. But you have to make sure the signs match the quadrant. That's the summation of what we just went over. Okay. Okay. Now, how are they used? Okay. Now, let me prove to you guys by converting degrees to radians that 30 degrees is equal to pi over 6. 45 degrees is equal to pi over 4. Okay. There's going to be 2 formulas. Okay. And remember, guys, right? Everything with a 6 in the bottom. That's my point, the square root of 3 over 2, 1/2. Everything with a 4 in the denominator, that's my point. Everything with a 3 in the denominator, this is my point. Okay, now, we're going to convert degrees to radian. Okay, let's start. Okay, this is a formula, guys. If you want to solve for radians, you're going to put the given degrees and multiply by pi radian over 180. Okay, here we go. Convert 30 degrees, right, to radian. We know 30 degrees is pi over 6, right? Because of the circle here, right? 30 degrees is equivalent to pi over 6. Now, okay, so let's use a formula to find the radian of 30 degrees. So it'll be 30 degrees times pi radian over 180. This is going to give us 30 degrees pi radian over 180. So we can cancel right? We can cancel the zeros or the degrees. Will be 3 over 18 will give us 3 pi over 18 radian, so it'll be pi over 6. Okay, now again, these are all these come from 2 special triangles, which I'm going to explain later on this PowerPoint. Okay, just 2. So for example, if you have something like pi over 10, right? You see it's not in the circle because it's in the circle, but it's not a perfect, one of those perfect triangles. Okay? But it's still there in the circle, but it's not a perfect, a perfect angle. Now, let's convert, right? So we know that pi over 6 is 30 degrees, right? This is my point. Now, let's convert the 45 degrees, right, to radian. We know it's pi over 4 because we saw that in the circle, but here's how you get it. We multiply 45 degrees times pi radian over 180. Right, so it's going to give us the degrees cancel. So we're there with 45 pi over 180 will give us pi over 4. See guys, 45 degrees is pi over 4. Now let's do the 60 degrees. We know 60 degrees is pi over 3, right? But here's how we get it. So we multiply 60 degrees times pi radian over 180. So it's going to give us 60 degrees pi radian over 180. Right, the degrees cancel. So there's a 0. So we're there with 6 pi over 18, which will reduce us to pi over 3. Okay, now, let's do some that are not perfect angles, like 65 degrees. Okay, let's see what it is in radian. So we multiply 65 degrees times pi radian over 180. It's going to give us 65 pi over 180. I think we can multiply everything by 5. So 5 times 13 will give us 65. 5 times 36 will give us a 180. The 5's, right, they cancel, or it's equal to 1. So we're there with 13 pi over 36. That's my answer. Let's do one more. Convert 200 degrees to radian. So we're going to multiply 200 times pi radian over 180, which will give us 20 pi over 18, which simplifies to 10 pi over 9. That's my answer. So 200 degrees is the same thing as 10 pi over 9. Now, let's go the other way around. Now let's convert radians to degrees. So for that, all we do is right, if we're looking for if we're looking for degrees, the degrees go on top. It'll be 180 degrees over pi radian. And we're looking for radian, the radian will be on top and the degrees will be on the bottom. This way they can cancel. Okay? Example, right? We know that pi over 6 is 30 degrees, correct? So let's see how we find it. So we use a formula to convert radians to degrees. So pi over 6 times 180 degrees over pi radian. You see guys, the pi's cancel. So 180 divided by 6 will give us 30 degrees. Now let's do the pi over 4. So pi over 4 to degrees. Again, we apply the formula. The pi's cancel. And 180 divided by 4 will give us a 45 degrees. Now let's do the pi. This is not in the circle, right? Pi over 5. But let's see what pi over 5 is in degrees. We multiply pi over 5 times the formula, right, which is 180 degrees divided by pi radian. The pi's cancel. So 180 divided by 5 will give us 36 degrees. So pi over 5 is equivalent to 36 degrees. Now how about pi over 12? Right? We do the same process. The pi's cancel. So 180 divided by 12 will give us 15 degrees. That's how you convert from radians to degrees and degrees to radians. Okay, now, here's what I was saying, guys, that everything is based on these two special triangles. For example, the 45, this is called a 45, 45, 90 degree triangle because everything in the triangle must add up to 180. Okay? And here is, guys, this is like the ratio. Okay? For example, these are called legs, leg and a leg, and this is called a hypotenuse. So, for example, this is 1 and that's 1, right? This is going to be square root of 2. Right, so this is my ratio here. Now, for the 30-60 degree, this is called a 30-60-90 degree triangle. And this is the ratio. This is called my short leg. This is called my long leg. This is called my hypotenuse, right? And here's the conversion, right? So this is x. If x is 1, then this will give us square root of 3, and they'll give us 2. Okay? Now, let me prove it to you guys. Where do these points come from? And also for the 45 degrees and the 30 and 60 degrees. Okay, now, right, these are my ratios here, right? So let's do this, right? So we can extend from the circle, right, all the way up and connect it. Now I'm going to take I'm going to take this triangle and put it over here. Now, isn't this equal to 1? So that's got to be 1. Now, isn't this equal to 1, right? Because all the way up, right, is also 1. So we know this is 1. Now, to find the hypotenuse, we can use the Pythagorean theorem. So a squared plus b squared equals c squared. C is always the hypotenuse. And the a and the b are the legs. So this is 1 squared plus 1 squared equals c squared. So they will give us 2 equals c squared. We square root both sides. So the square root of 2 equals to c. That's my c. Okay? Okay, now. Hey guys, you see, so this is, I just brought the last triangle, right? I brought it over here to the next slide. Okay, now, hey guys, the x and the y is equal to cosine and sine. The x is the cosine and the y is my sine. And also the x is equal to cosine and it's called adjacent over hypotenuse. Okay? And y is the cosine and is equal to opposite over hypotenuse. Now, here's what we mean by opposite, hypotenuse, and adjacent. Okay, say this is my angle, correct? This side is opposite, it's called opposite, the opposite side from the angle. The one here at the bottom is called the adjacent side because it's adjacent to the angle. And this is my c, right? This is always my hypotenuse, which will be my c, which we call it the hypotenuse. Okay, now, right, we know, let's find the x value, right? We know it's square root of 2 over 2. Let's see if it comes out. So x equals to cosine is going to be adjacent, right, over hypotenuse. So the adjacent will be 1, and the hypotenuse will be square root of 2. Now, you have to rationalize the denominator. So we multiply both top and bottom by square root of 2, right? Because on the bottom, we don't want it to be like a radical. So it's going to give us the square root of 2 over square root of 4. The square root of 4 is equal to 2. You see, guys, that's where the point comes from. For the x value. For the y value, guys, it's the same thing, right? Because they're the same, so it's going to give us the same result. This is how we know that everything with a 4 on the bottom, this is my point. It's 45 degrees. Right, so pi over 4 is equal to 45 degrees, and it's equal to square root of 2 over 2, square root of 2 over 2. Now comes the 30, 60, 90 degree triangle, okay? And these are my ratios. This is called the short leg. This is called my long leg. This is called my hypotenuse. Now, if the short leg is equal to 1, right? And the long leg will be 1 times square root of 3 will give us square root of 3. And 2 times 1, because x is a short leg, will give us 2. Okay, now, let's do the same thing as before, right? Isn't this equal to 1? But here, guys, they put the 1 here, guys, because this is my short leg. But I'm going to prove to you that this is equal to 1, okay? So if that's 1, right, this is 2, and this will be square root of 3. Okay, now let me prove to you guys by using the Pythagorean theorem that this is equal to 1, right? Because this is 1 from here to here is 1. Because it's a unit circle, which is unit means 1. Okay, now. So this is my theta. This is 1, right? So this got to be 1, right? Okay, now. This will be x. And this will give us 2x, according to the ratio here. Okay, now. Let me use the Pythagorean theorem here, guys, okay? So it's going to be 1 squared plus x squared equals to 2x squared. It's going to give us 1 plus x squared plus 4x squared. Now we're starting for x, so I'm going to subtract x squared to both sides. So I get 1 equals to 3x squared divide both sides by 3. Right, so 1/3 equals to x squared. Now we take the square root. So x equals to the square root of 1/3, which is 1 over square root of 3. That's my x, right? So this is equal to the x equals to 1 over square root of 3. Now the 2x, right? So it's going to be 2, right? So this is my short leg, the x, which is 1 over square root of 3. This is my long leg, right? And right, because it's equal to x square root of 3. And right, and what was x? It wasn't x, the same thing as 1 over square root of 3. You see, so I'm going to plug in 1 square root of 3 for the x. We multiply them, and it's equal to 1. You see, that was trying to prove that this is equal to 1. Then the hypotenuse will be 2x, so we multiply 2 times x, which is 1 over square root of 3. And this is my hypotenuse. Hey guys, this point here, guys, was only to prove to you guys that this is equal to 1, right? Because from here to here is 1. Okay, now, but this here, guys, is my ratio. Okay, that's the triangle that I'm going to take to the next slide. There it is. Okay, now, by applying the same concept as with a 45, 90-degree triangle. Right, x equals to cosine of theta, which is equal to adjacent over hypotenuse, and y is equal to sine theta, which is equal to opposite over hypotenuse. And here's my triangle, right? This is the opposite, adjacent, and hypotenuse. Okay, now, let's first find, right, we're looking for 30 degrees, right, which is a pi over 6. X equals, right, to adjacent. Adjacent means the square root of 3, right? So it'll be square root of 3 over 2 because adjacent or hypotenuse. Now for the y, right, the y is a sine, which is equal to opposite over hypotenuse. So opposite of the angle here will be 1, and my hypotenuse will be 2. So it's 1/2. You see, that's where the point comes from, guys, for the 30 degrees over the pi over 6. Okay, now let's do the other one, right? Now let's do the 60 degrees. So for the 60 degrees, guys, if you notice, the angle's up here because this is at 30 degrees, this is 60 degrees, and this is 90 degrees, right? Because it's a right triangle. So now, instead of finding the angle here on the left, right, we're looking for the one up here because this is the one that's 60 degrees. Okay, now, let's first get the cosine. Right, that's my angle. This is opposite, adjacent, hypotenuse, because now this is the angle that we're looking for, which is the 60 degrees angle. So the cosine, right, is adjacent. Adjacent will be 1, and hypotenuse will be 2, so it'll be 1/2. For the y, right, is equal to the sine, which is opposite over hypotenuse. So opposite will be square root of 3, and the hypotenuse will be 2. You see, guys, those are my points. Again, this is where all the points come from. Okay? In mathematics, guys, it's always good as an instructor to prove why certain things are the way they are. Okay? I know the students at times they believe us, right? But at times it's always good to show them the proof where things come from. Okay, now, so the pi over 3 is equal to 60 degrees, which is 1/2 square root of 3 over 2. So these points are the ones that are in the unit circle. Okay, now we have to know the 6 trigonometric functions because these are useful when solving word problems. Okay, now these are the most known 3: the cosine, the sine, and the tangent. Now, there's going to be 3 more, which is the secant, cosecant, and cotangent. Okay, now guys, the cosine and the secant are called opposite reciprocals. So in other words, when you find the cosine, you also have found the secant, because the secant, all you do is flip it, right? So all you do is invert it. Now it's going to be hypotenuse over adjacent. Once you find the sine, you also have found the cosecant, because the cosecant, all you do is invert the numerator with the denominator on the sine, so it'll be the reciprocal, which will be hypotenuse over opposite. And the cotangent is a reciprocal of the tangent. Okay, let's do an example here. Say they give us again, this opposite, adjacent, hypotenuse. Find the 6 trig functions of pi over 6. Okay, now. You guys remember, guys, this is 1. It was square root of 3 because this is the 60 60 90 degree triangle. Okay, now. For the pi over 6, right? So for the cosine, is going to be adjacent, which will be square root of 3, over hypotenuse will be square root of 3 over 2. Right, there it is. Once you find the cosine, right? And but let's do this first. The cosine, sine, and tangent. The sine will be opposite over hypotenuse. Now the tangent is opposite, which is 1 over square root of 3. Now, once we found these, the main 3, we can find the other ones. The secant is the cosine, but the reciprocal. Now, you have to rationalize the denominator, so I multiply top and bottom by square root of 3. It's going to give us 2 square root of 3 over 3. The secant, right, we use a reciprocal for the sine, which will give us 2 over 1, which will just give us 2. The cotangent, right, we do the reciprocal of the tangent, which will give us the square root of 3 over 1. Now, let's go back and simplify the tangent. So we multiply top and bottom by square root of 3, right, which will give us square root of 3 over 3. So this is what I tell my students, guys. Every single radian with a 6 in the denominator, this is my cosine, that's my sine, that's my tangent, that's my secant, cosecant, and cotangent. But it depends on the quadrant whether they're positive or negative. Okay, now, here's another example. Find the exact values of the 6 trig functions of the angle theta. Okay, now, right, we have this is theta, this is angle A, angle B, and angle C. So the length of AC, right, is equal to 8. The length of BC is equal to 6. What's missing? We're missing the hypotenuse. Okay, so for that, we're going to use the Pythagorean theorem. So, hey guys, it doesn't matter what the 8 or the 6 are. This can be A or this can be B or vice versa. This can be B or this can be A. It doesn't matter. What matters is that C is always the hypotenuse. Here, guys, I just let A be my 8 and B 6, guys. But check this out, guys. In reality, guys, if this angle B, this is what you're going to learn later on. This angle B, guys, this is called little b, right? Because the opposite, the opposite side from the angle is my lowercase b. So this should be little b, this should be little a, and that should be little c. Okay. But for now, guys, it doesn't matter. But once we get to that section, guys, it will matter. Okay, because they're going to want you to find the angles A, B, and C, and find the length, right? So this will be little b, that'll be little a, and that'll be little c. But for now, guys, we'll just leave it like this. So it's going to give us 64 plus 36. It's going to give us 100 equals to c squared. We take the square root of both sides, so c equals 10. So I know that my hypotenuse is equal to 10. Okay. Now, let's find the 6 trig functions. Again, opposite, adjacent, hypotenuse. That's 8. Opposite is 6. Hypotenuse is 10. So cosine, right? Cosine is adjacent, will be 8 over 10. Opposite, let's put them on here, guys. I'm sorry about that. This will give us 8 over 10. Simplifies to 4/5. Okay, now, once I find the cosine, I also find my secant. The secant will be the reciprocal of the cosine, will give us 5 over 4. The sine, right, is opposite, which would be 6, over hypotenuse, which would be 10. 6 over 10 simplifies to 3/5. So once we find the sine, we also find the cosecant. All we do is use the reciprocal, so it'll be 5 over 3. The tangent is opposite over adjacent, so it'll be 6 over 8. Right, simplify will give us 3/4. Now, the cotangent is the reciprocal of the tangent, which will be 4 over 3. These are my 6 trig functions. Okay. Okay, now, how do you apply them in real life? Okay, here we go. This is number 64 from, I think, from section 4.3, I believe. It says, a biologist wants to know the width W of a river. From point A, the biologist walks downstream 100 feet and size to point C. See the figure. Okay. Okay, here it is, right? Let's see. Okay, a biologist wants to know the width, right? This is the width he wants to know of the river. From point A, right, walks downstream 100 feet and size to a point C, right? So he knows that this is 54 degrees. From the sign, it is determined that the angle is 54 degrees. Now, how wide is the river? Okay, now, hey guys, with the given information, we have to know which trig functions to use. Hey guys, the most common one is going to be the top 3, which is a cosine, sine, and tangent. Okay, now let's see what they give us. You see, guys, we're looking for the opposite, right? Because this angle, we're looking for the opposite. So it's got to be something that has opposite. It cannot be the cosine. It has to be the sine with a tangent. Okay, but check this out. They also give us the angle, and they give us, right, the adjacent. So it cannot be the sine either, because the sine needs a hypotenuse, and this is my hypotenuse, which is not given. So we're going to use a tangent. Opposite, right? The adjacent. So we're going to use a tangent. Tangent of theta is equal to opposite over adjacent. So a tangent of 54 degrees equals to the opposite, which is the width of the river, over 100. But here, guys, right, I'm going to swap the tangent of 54 comes down to 100, and the 100 comes over here. This is using the ratios, right? Because over here, guys, there's like a 1 here at the bottom. So we can switch these two. Or we can multiply both sides by 100 and then divide by tangent of 54, which we get the same thing. Now we use a calculator. So it'll be about 137.6 feet. That's the width of the river. You see, guys, that's why these trig functions are useful in a real life situation. Now let's do another one. It says a guide wire runs from the ground to a cell tower. The wire is attached to the cell tower 150 feet above the ground. The angle formed between the wire and the ground is 43 degrees. See the figure? There it is, guys. This is my guide wire, right? They're saying that this is the height is 150 feet, and the angle formed between the wire and the ground is 43 degrees. So what are we looking for? How long is the wire? So we're looking for for this right here. We're looking for the wire. So we're looking for the hypotenuse. And for you guys, how far from the base of the tower, right? This is my tower. How far from the base of the tower to the guide wire anchor to the ground? So we're looking for this, which would be the adjacent. So for part A, we're looking for the hypotenuse. For part B, we're looking for the adjacent. Okay. Okay. Now, what's given? You see, guys, what's given, guys, right, is the opposite. So we have to use something that has opposite. Okay. So which one has opposite? The sine and the tangent, right? The cosine doesn't have opposite, right? So we cannot use we can use a cosine. So for part A, right, we're looking for the hypotenuse, right, for the wire. So we're going to look for opposite over hypotenuse. So we're going to use a sine, right? So it'll be the sine of 43 degrees equals to opposite, which is 150, over hypotenuse. Again, we're going to switch these two, so hypotenuse goes over here to the left. The hypotenuse is equal to 150 over sine of 43 degrees. Now we're going to use a calculator, but you have to make sure that the mode is in degrees. It's going to give us something like 219.9 feet, approximately 219.9 feet, or 220 feet. That's the length of the wire. Okay, now for part B, right, we're going to use a tangent because the tangent has opposite over adjacent. So give me a tangent. So tangent of 43 degrees equals to 150 over adjacent. Okay, now we're going to do the same thing as what we did here on the sine, right? So it'll be adjacent equals to 150 divided by tangent of 43 degrees. Use your calculator, and you get something like 160.9 feet. That's the answer for B. Okay. Okay, now we're going to do is arc length. Okay. I think this is from section 4.1, guys. Okay. I know that some for example, the inner circle is from section 4.2. The six-ring functions come from section 4.3. But now I have to cover also something from section 4.1. Okay, for the circle of a radius r, the central angle theta intercepts the arc length. The arc of the length is given by S is equal to r theta. The S is the length of the circular arc. Okay, and theta is measured in radians. That's where the mistake that a lot of students make. You have to convert theta to radians, and r is the radius. Okay, example. A circle has a radius of 4 inches. Find the length of the arc intercepted by the central angle of 240 degrees, as shown in figure below. Okay. So here, guys, what they want, right? They want this arc length here, guys. This is what they want here, the arc length. And the 240, guys, is my central angle. And the radius is 4. Right, so this is my formula, guys. What do we need? First of all, guys, I need to convert, right? Because theta has to be in radians. And this is not in radians, it's in degrees. So I have to convert 240 degrees to radians. Because remember, guys, right? Which of the two formulas are we going to use? If we want radian, the radian must be on top. See, there it is on the formula. So we're going to multiply 240 times pi radian over 180, right? It's going to give us 4 pi over 3. So it reduces to 4 pi over 3. Okay, now. So now, let's plug everything into the formula, right? My radius is 4 inches, and my theta is 240 degrees. Converted to radians will give us 4 pi over 3. This will give us 16 pi over 3. Approximately, guys, it's going to give us something like 16.76 inches. So this arc length is equal to 16.76 inches. Now, let's do another formula here, guys. This is called the area of a sector, right? This is called the sector, right? This is the area that they're looking for. For a circle of radius r, right? This is my radius r. The area of the sector of the circle with a central angle, right? This is my central angle. And this is your formula. The area equals to 1/2 r squared theta. Again, theta must be in radians, right? So we have to convert first. If it's in degrees, convert it to radians. Example: a sprinkler on a golf course fairway sprays water over a distance of 70 feet and rotates through an angle of 120 degrees, as shown in the figure below. Okay, this is what it means, right? So this is a sprinkler, guys. It's going to go like this, back and forth, right? So this is my radius here. The 70 is my radius, and my central angle is 120. So we need to find the area of the fairway watered by the sprinkler. So we want to find how much area was watered by the sprinkler, all this area here. So there's my formula. So first I need to convert the 120 into radians. This is going to give us 120 pi radians over 180. It's going to give us 2 pi over 3. Okay. So I already have all the info. Right? So it's going to be my radius is 70, so it'll be 70 squared times 2 pi over 3. Right here, guys, the 2 on the 2 pi cancels with the 2 on the bottom. So it's going to give us 490 pi, 4,100 pi over 3. So the area, this is the exact area, but they want you to round off to the 10th place. So it's going to give us something 5,131 square feet. That's how much. The area of the golf course was watered. Okay. Now, this comes from section 4.4. Hey guys, now this one here, guys, is trigonometric functions of any angle. Up to this point, we've done only acute angles, something 90 degrees or less. Now we can do any angle on the unit circle. Okay, so so this is my r. The r, guys, is a distance from the origin to any point. So we know that cosine theta, right? So cosine theta is equal to x over r. This is the formula, guys, here. So as my cosine, my secant will be r over x. And my sine is y over r. Then my cosecant will be r over y because they're reciprocals of each other. And my tangent is y over x. Then my cotangent will be x over y. Okay. Okay, now this is crucial to know, guys. Because if you notice, right, this is quadrant 1. Everything is positive, the sine, cosine, and tangent, because the tangent is equal to y over x. So if or sine over cosine, if they're both positive, then the tangent will be positive. In quadrant 2, the sine is positive, which is my y, the cosine is negative, which is my x, and also the tangent is negative because a positive and a negative will give you a negative. In quadrant 3, the sine and the cosine are both negatives because my x and my y are both negatives. But my tangent is positive. Why? Because y over x, because negative over negative will give you a positive. So every time that the signs are the same, the signs are the same, both positive or negative, the tangent will always be positive. And in quadrant 4, my sine is negative, my cosine is positive, and my tangent is negative. That's what you have to know, guys, okay? Okay, now example. It says here, let the point negative 3, 4 be on a point on the terminal side of theta. Find the sine, cosine, and tangent of theta. Okay? So here, guys, we need to know the quadrant the point is on. I need to find r, right? So we know it's quadrant 2. Right? Quadrant 2. Which means the sine is going to be positive, the cosine negative, and my tangent negative. And also, guys, we need to find r. And r equals to the square root of x squared plus y squared. So let's plug in my x is negative 3 and my y is 4. Let's plug him in there. So it's going to give us 9 plus 16 will give us the square root of 25 will give us 5. So I know my r is 5. So, right, so I have my all the 3 components, my x, my y, and my r. So the sine is y over r, right? So it's going to be y, it will be 4 over 5. My cosine is x over r, will give us negative 3 over 5. And my tangent is y over x, will give us negative 4 over 3. Right? And again, quadrant 2, my sine is positive, my cosine is negative, and my tangent is negative. Okay, now I believe this will be the last one here. Let me see what time it is. We got about 5 minutes. Hey guys, here's where they give you here. They give us here's where a lot of students make mistakes. Okay, as my experience as an instructor. Here they tell you given that theta is equal to negative 5/4 and the cosine of theta is positive, more than 0. Find the sine of theta and secant theta. Okay. So what should we do first? We need to know the intersection quadrant of both conditions, right? This is condition 1, the tangent is negative. This is condition 2, the cosine is positive. And also we need to find r. But first, let's find the intersection of the tangents, of the quadrants. Okay, we notice, guys, that tangent is negative in quadrant 2 and quadrant 4. Okay, now we know that the cosine is positive in quadrants 1 and quadrant 4. Okay, where do they intersect? Well, is it in quadrant 4? So the answer is in quadrant 4. So quadrant 4, we know that my sine is going to be negative. Guys, and the secant, right, is the reciprocal of the cosine. So I know the secant is going to be positive because the secant is the reciprocal of the cosine. So I know that's going to be negative and a positive. Okay, now let's find them. Right, so we know that tangent, right, is y over x. So we know what the y is and what the x is. X is 4 and y is negative 5. Y is negative 5 because negative 5 is in quadrant 4, right? The y is negative in quadrant 4. Now I need to find r. The formula, right? So we're going to plug the 4 and the negative 5 in there. So it's going to give us r is equal to the square root of 41. That's my r. Now the sine is equal to y over r. So the sine will be negative 5 over the square root of 41. Okay, but now they want you to rationalize the denominator. So I multiply top and bottom by square root of 41, and it's going to give us negative 5 square root of 41 over 41. That's the answer for the sine. Now we know, right, that the secant and the cosine are opposite reciprocals. If the cosine is x over r, then my secant will be r over x. My r is the square root of 41, and my x is 4. These are my answers, guys, right there. Now, guys, okay, we're done. But again, I'm gonna emphasize how important the unit circle is. So let's summarize it again. This is what you gotta know, guys, for week 1. You gotta know how to construct a circle. Okay, so let's do like another summary. So for part 1, right, we divide the circle into 8 equal parts. The first part, we start with 0 and go all the way. We keep adding pi over 4 until we get to 8 pi over 4 and then simplify, right? And then every radian with a 4 in the denominator has my point. So that's my point, right? These are the points. So every radian with a 4 in the denominator, that's my point. It's going to go there. Quadrant 2 is going to be negative, positive. Quadrant 3, negative, negative. And quadrant 4, positive, negative. That's the first part, right? First part. Second part, right? We're going to do the same thing, but we're going to divide the circle into 12 equal parts. Right? And then we start with 0, and we keep going all the way. We keep adding pi, and then we simplify. With the degrees, we start with 0, and we add 30 degrees until we get to 360. Now, every radian with a 6 in the denominator, this is my point. So it's going to be at pi over 6. Make sure that signs match the quadrant, so both are going to be positive. At 5 pi over 6 is going to be negative, positive. At 7 pi over 6 is going to be negative, negative. At 11 pi over 6 is going to be positive, negative. And every radian with a 3 in the bottom, in the denominator, this is my point, 1/2 square root of 3 over 2. So it will be in quadrant 1 at pi over 3, both going to be positive. In quadrant 2, the 2 pi over 3 is going to be negative, positive. In quadrant 4, the 4 pi over 3, they're both going to be negative. And finally, at 5 pi over 3, which is quadrant 4, it's going to be positive, negative. And that's today's presentation, right? And this is what I gave my students on the exam for them to fill it out. Okay, so please, guys, try to understand the inner circle. It's going to help you in the long run. Thank you. Let me go back to your host.
Thank you, Mr. Isasi, for a wonderful presentation. We do want to remind all of you about our previously recorded sessions, which are available on the YouTube playlist. Today's session will also be available on the playlist later on today. Also linked is a short survey to help us improve our TVE sessions, so please take time to fill out the survey. Before you leave, I want to share the TVE sessions that we'll have next week. We'll be back with Happy Math Hour next week, which we will be covering Math 1332. In the session for 1332, we'll be covering the set theory, basic properties of the sets, complements, subsets, and the Venn diagrams. And in Math 2412 session, we will be covering the trigonometric graphs. And for next week, we will have the student success topic covering Open Computer Lab and ISC. Don't forget that we also have a student success topic today at 1. So if you want to come back and join us. And thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use the chat box or mic. And good luck this semester, guys.
Thank you, my friend.
You're welcome, Mr. Isasi.